The monetary circuit is a macroeconomic model where credit is assumed to precede any productive activity, and that credit flows into purchasing power through production and then consumption. The circuit is then closed by the paying back of the initial loan, and the credit is considered to be destroyed. Thus, we have the creation and destruction of moneyness as credit, which drives the economic system. To put this school in historical context, you can roughly think of neoclassicism from Marshall evolving along to Keynes, at which point there's a split, and that split has to do with whether or not money needs to be explicitly addressed in models. One branch continued with the understanding that the monetary nature of our economic system made it qualitatively different from a sophisticated barter economy, and therefore money needed to be accounted for in models, often literally. This branch could be described as the Cambridge School. The other branch assumed that money could be ignored in modeling because it's merely an instrument to aid exchange and doesn't impact the system dynamics. This is what's currently taught in 99% of econ courses. Two famous controversies that illustrate this divide are the capital controversy and the monetarist controversy. The capital controversy, cutely known as the Cambridge controversy, since the antagonists were all located in places named Cambridge, was about whether interest rates could be determined from the amount of savings, given that the amount of savings itself is determined by interest rates. The main players here were Joan Robinson and Piero Sraffa in the UK, and Paul Samuelson and Robert Solow at MIT. The MIT people said yes, the Cambridge people said no. The monetarist controversy was about the relative effectiveness of fiscal policy, i.e. government spending, versus monetary policy, such as Federal Reserve interest rate setting. Again, the debate was about the endogeneity of money effects. The neoclassicists, represented by Milton Friedman and David Meisselman at the University of Chicago, claimed the money supply could be exogenously specified. The Cambridge School, which included many Italian and other immigrant economists, and represented in this case by Albert Ando and Franco Modigliani, claimed that modeling needed to use an effective money supply, which was endogenously determined, since households and businesses would not necessarily spend consistent with the full money supply, and government spending was likewise endogenous, as it would be a function of this effective money supply. The last name initials of the antagonists on the two sides, AM and FM, led to another cute moniker, the radio stations debate. Today, it's easy to see these controversies, taken in the context of the Cold War, as fundamentally ideological, about free markets versus social expenditures, with each contingent manufacturing facts out of the mathematics. But even socially minded economists such as Joseph Stiglitz promoted the neoclassical modeling framework because taking endogeneity into account made the math intractable, or at best showed multiple solutions. The sense was that clear solutions, however heroic the assumptions behind them, were better for theory development than unclear solutions. All modeling efforts face these epistemological questions, but I'll add that one of the most exciting aspects of applying complexity methods to economic questions is that they offer the possibility of rigorous analyses that include endogenous effects. Back to the monetary circuit. Augusto Granzini, out of the Cambridge School branch, posited the monetary circuit in the late 1980s and framed it as follows. A firm plans production based on expected effective demand. Firms obtain credit to finance production through money creation, known as endogenous money, as in it's not created by a state or central bank. Once money is created and in the firm's deposit account, the firm uses this money to pay for materials and wages to produce a set of goods. The firm sells the goods to the same population that made the goods and received the wages. The firm pays back the bank to the extent it can. Banks are understood to be constrained only by a lack of creditworthy clients, not by deposits. Endogenous money emerges by something called ex nihilo, or out of nothing, rather than being inserted into the system by a non-economic actor as exogenous money. Now, the first part of this cycle, where the firms obtain bank funding, produce, and disperse wages, is known as the efflux phase, whereas the firms paying the banks back is known as the reflux phase. The funds arising from the original loan get paid out to workers in order to produce goods. Those same wages are used to buy said goods, and the income from those wages are used to pay back the initial bank loan. The debate between the branches described above could also be described as contrasting the monetary perspective and Say's law. Say's law claims that production will encourage other production since, in an exchange economy, anything produced should be exchanged. Thus, any production incurs additional production to create opportunities for exchange. This can be expressed symbolically as CMC, commodity, money, commodity, where money simply mediates exchange between commodities, thus is unimportant to economic dynamics. But if the point of production is profit, we have MCM, where commodities mediates between accumulating money and accumulating money. This is what is expressed in the monetary circuit. The circuitists, as they like to be called, ponder how this closed production, consumption, investment cycle succeeds in making profit and paying off investment loans. In the original Granzini framing, at best, firms could recoup the money spent, but households may not spend all income depending on their preference for liquidity or hoarding. Therefore, firm revenues are often less than the loan, and the firm cannot pay back the loan in a given cycle and needs to borrow again to start another credit cycle, and production therefore conducts itself in a state of permanent indebtedness. Monetary circuits are a form of what's known as stock flow consistent modeling, where all aspects of the system need to be accounted for such that everything sums to zero. Think balance sheets and income expenditure statements. Which leads to the point that one needs to be very clear about whether one is talking about stocks or about flows. Michael Kalecki, another Cambridge School economist, who like Walras started his career as an engineer, observed that economics, as far as he could tell, was the science of confusing stocks with flows. Steve Keen presents a nonlinear dynamical model of the monetary circuit, demonstrating that any perceived lack of profit in a closed system is a manifestation of this confusion of stocks and flows. This paper is in your reading list. Keen also objects to the concept of the destruction of money in the reflux stage, suggesting that this repaid low money still exists to be lent again. We'll talk about a similar model here because the stock flow distinction is critical and indicative of complexity thinking. The model consists of a system of differential equations with the variables F, which represent firm accounts, H, which are household accounts, and R, which are bank reserves, which represent the bank's cash. Banks make loans to firms, collect interest on those loans, and pay interest on both firm and household deposit accounts. Banks also consume products that enable them to do their work. Households consume the products produced by the firms using their wages. Here's the system of dynamical equations which govern changes in the various accounts. So the change in the firm account equals the deposit interest from that account minus the loan interest minus the wages it pays out plus the income it gets from the bank and plus the revenues it makes from the households. The change in the reserve accounts is going to be the loan revenue it makes, what it pays out in deposit interest for the firms and deposit interest for the households, minus what it spends to conduct business. And the change in the household account is going to be deposit interest from the bank on its account, plus the wages from the firm minus what it spends in consumption. Banks have to consume, otherwise all money eventually goes to them because they aren't paying anything out in this setup otherwise. This can also be modified. For example, bank outlay could represent additional loans, and you'll see some of that done in the Keene paper. Now let's talk about these parameters, this W, beta, and omega. So let's say that there are 6 production cycles a year, which means that the firm produces something, pays out wages 6 times a year, which means every 2 months. And let's say that firms get 1/3 of the revenue that they produce, which means that the workers' share of the revenue is 2/3. So this W parameter is going to be the worker share times the number of production cycles. So you get 1 minus 1/3, which is 2/3 times 6, which equals 4. So that W from the previous slide, looking at the changes in the equations, represents 4. And this is what it stands for. This is out of the Keene paper. Omega is going to be the number of consumption cycles, and there's 26 consumption cycles in a year, which means that the households consume every 2 weeks. Beta governs the consumption by the banks, and we also note that the interest is paid yearly. L equals your original loan amount, which is set for 100. And the loan interest rate, I sub L, is 5%, and the deposit interest rate, I sub D, is 1%. Note the differing lag times in the cycles. This is very important for the Keynes monetary circuit model. Okay, let's look at our results. So the blue line at the top is the quantity of the firm account, and so that's about 84. The green line is the quantity in the household account, that's about 13, and the bank reserve account is about 4. Notice that all of these add up to 100. So this is where the original circuitous would say, how is it possible that profit is being made if everything adds up to 100? Well, here's how we look at it in terms of flows. This is the stock picture. Let's look at the flow picture. Okay, so let's pretend that this cylinder represents the household account and how much is in that bucket, so to speak. Now what you have flowing into the bucket are wages and interest, and flowing out of the bucket is consumption that happens every 2 weeks. Now what that stock picture we saw on the other page was the equilibrium amount that would be in the household account, and that's going to be 13. So we're going to call that loosely the average amount. So with 26 flow cycles, we go 13 times 26, and that equals 338 total flow. Well, we can see that that's much greater than 3 times the actual loan. This is why the flow picture is so important. Now, this is also known as something called the velocity of money, which you may have heard of. Now let's think about profit. Remember that the firm got 1/3 of revenues. So 1/3 of the revenues goes to profit, is dispersed 6 times per year. Remember, because the production cycle was 6 times per year, every 2 months. So that amount was 84. So 84 divided by 3 for the firm's share times the number of distribution cycles, you get to be 167, which is over 1.5 times the loan amount. Thus, the firms can pay back the banks the interest on loan servicing and still have a monetary surplus. Keynes' model refers to the households as workers and the firms as capitalists. I am now going to express an opinion. Banks and firms both serve vital functions in the economy, and they don't describe classes. Banks are owned by individuals who live in households, as do firm owners. It would be helpful to have an economic framework that, 1, accounts for different uses of money, both productive and non-productive, and the dynamical consequences of these uses, and 2, acknowledges the central question of the distribution of the wondrous returns to division of labor production, as well as the drivers that increase those returns, without defining these questions in terms that pit workers against capitalists. The definitions and language arising from this historic contest are not only old and tired, their continued pervasiveness impedes the advancement of economic theory, which is ready for new perspectives and framings. Okay, back to the monetary circuit. Since money is assumed to be created from nothing by banks each cycle to keep production going, proponents of modern monetary theory, MMT, suggest that if banks are already creating money to enable production, and this is considered business as usual, there's no reason why the banks couldn't also create money for government spending programs, which enhance effective demand through all the usual Keynesian pathways. The monetary circuit framing can also be used to explore other consequences of money in our modern economic system. For example, here's what might happen to our circuit with an MMM component. So here the households, rather than spending on consumption, are spending on assets in the financial market. Well, firms can do that as well, and so can banks. Here we see that the MMM activity could serve both as a sink or a source of exchange money. The concept of the monetary circuit is simple yet powerful and provides a broad platform for extension in multiple directions. One of those directions is stock flow consistent modeling, which I mentioned earlier, known as SFCs. Historical development aside, monetary circuit models could properly be considered a subset of SFC models. The benchmark version of SFCs is the comprehensive macroeconomic model developed by Wynne Godley and Mark Lavoie and explained in their book Monetary Economics. Both monetary circuit and stock flow consistent models are defined by stock flow consistency, where money and materials always come from somewhere and go somewhere, and the attention to endogenous money, credit money created within the system via banks. You could think of monetary circuit models as focusing on systemic monetary dynamics and their effects, while stock flow consistent models describe more or less comprehensive macroeconomic systems using endogenous money. These are usually set up as dynamical models with often vast systems of equations and hundreds of parameters. ABMs are starting to make headway here, and the best known is the EURACE model, a behemoth representing the entire European economy.